Shemesh, my name is Borat. Welcome to Physics 105. Today we are talking about the P and an M and a B. The P is a pizza, and the MB is a meat and vegetable.
No, Kanishka, that's not what P and MV stand for.
Yes, it is.
No,
it
it
is
is
drawn. Now it is law.
P means momentum. The momentum of an object is actually its mass times its velocity. Now, velocity is a vector because it has both magnitude and direction, which you've already learned. Because of that, P is also a vector. It has a direction, so there's a direction that your momentum is going in, as well as a magnitude.
Stop.
Now, if you can recall, as Newton said, the sum of all forces is equal to an object's mass times its acceleration. Now, the acceleration is based off its center of mass, because if you have a large object, you want to measure it from its exact center.
Large like my shoe?
It could be your shoe. That works. See, the thing about his shoe is it's not shaped like a round object, so you would use the center of the object, as you had learned earlier in this chapter. Now, acceleration is your total, or your delta V, which is your difference in velocities. And now velocity is a vector, remember, all over your delta T, which is your difference in time, still multiplied by your mass. Now, you can now take your mass and multiply it in, so now that you have delta mv, which is still a vector, all over delta t, and you get mv, as we had up here, is equal to momentum. Therefore, your sum of all forces external, remember this is only external because internal, as you will learn later, is conservation of momentum, is equal to your difference in momentum divided by your difference in time. So, remember, obviously, if you have delta t on the bottom, it can't equal 0. So, if all of your sum of forces is equal to 0, then your delta p has to be 0. And since delta p is equal to final momentum minus initial momentum, then when all forces is equal to 0, momentum is conserved, which is the basis for most of physics. Momentum conservation.
So on. Rocket problem.
Damn you, more TV.
So your total mass, which is your mass of the rocket plus the mass of the fuel, times the velocity that it's initially moving at, is your initial momentum. Now this is moving in a positive direction, so the magnitude as well as the direction is going to be a positive number. So this is equal to your final momentum. Final momentum can be split into two things. Your final momentum of the rocket itself without the fuel, and the final momentum of the fuel. Now remember, the fuel is moving in the opposite direction, so it's going to have to be negative.
Asher, what are this?
I don't know, Kanishka. Now, your mass of the rocket itself is your total mass minus the differential mass of the fuel, dm. That's the mass of the rocket. Your velocity is the velocity initial plus the differential increase in your velocity gained from the actual explosion itself where the fuel is being launched. So your velocity is v plus dv.
Asher, what are this?
Don't know, Kanishka. Now, for the fuel itself, the fuel is the differential mass of the fuel, so that's the mass that you use for that. As far as the velocity goes, it's the actual muzzle velocity, u. That's the speed that it launches out of the rocket from respect of the rocket. But because you want it from respect of the person that's observing, that little guy, as mv is, you're going to want to subtract the velocity of the rocket, which is v plus dv. So you have negative dm all times u minus v plus dv.
Asher, I found a water gun.
Good for you. Well, thank you. So, simple foiling, mv is equal to mv plus mdv minus dmv minus dmdv. And then this one is minus dmu minus dmu times negative u, which is just plus dmu, and the same for this, which ends up being plus dmdv. You can cross out the mv's, you can cross out the dmv's, you can cross out the dmdu's because they all cancel with each other, and you're left with this lovely thing. Bring this over to the other side and you get this. Now, dm is the differential mass of the fuel. So dm is equal to the negative differential mass of the fuel. Remember, this is big M. Big M is the total mass. So, when you plug that in here, dm equals negative dm. Negative dmu equals mdv.
Damn you, more DV.
Damn you, more TV! Damn you, more TV! Damn you, more TV!
Damn you, more DV. Yeah, right.
Activating now. I've stolen this packet and a camera from Asher. I will now teach you real physics. This is a good thing. Oh, when a car collides with each other, it is a good thing. Hello. I found this guy. Hello.
Sorry,
My name is Borat.
And you're back here because
I'm filming away from Asher.
Like
Asher has found me! Yes, Shamash. I'm now going to teach you some physics because Asher has me at gunpoint as usual. You might be able to trust something. Yeah. Let us begin with the collisions. There are three kinds. Oh, one is an inelastic. Inelastic. One is completely inelastic, and one is, you guessed it, elastic. Now, in inelastic collision, well, in any collision, P is conserved. So that means PF minus PI will equal 0. So M momentum is the same for all of the time. Do not fear. So, number 1, delta P equal to 0. Do not fear. Number 2, in an inelastic collision, if two things hit, they will bounce apart. Do not fear. So they will bounce off. And then thirdly, kinetic energy is not conserved. So you add all the kinetic energies in the beginning and all the kinetic energies at the end, and it will be different more. You cannot count on it being the same. Secondly, completely inelastic. As usual, delta P equals 0. Now, and when a completely inelastic collision, if a two things collide, they stick it together. Very nice. So that happened, but the kinetic energy not conserved. Do not count on that ever happening, unless of course it is elastic. Like all collision, delta P is 0, and they also bounce apart. So that is like, it is like boom. They are not stuck or anything like that. And when it is an elastic collision, kinetic energy initial will equal kinetic energy final. Now there is one more kind, which is an explosion. And an explosion is the complete opposite of completely inelastic. Instead of sticking, something that is already stuck will break apart. So you have it here, and then explosion happen, and this guy fall here in a projectile motion. We have to go here, and to break apart, I want to go here, I want to go here. So you see, that is how it happens. We Cinque. Yichmesh, I apologize again for being legitimate, but Asher has me at gunpoint as usual. I cannot do anything. I am being held against my will. Please call my mother. Sorry, Asher. Let us begin. So there are three cases if a second ball is stopped. One case, it is mass 1 and velocity 1 and mass 2. So there are three cases. Mass 1 equals mass 2, mass 1 greater than a mass 2, and a mass 1 is less than a mass 2. Okay, well here's what happens. When it goes the first time and they are equal, what will happen is mass 1 will stop where mass 2 was, and then mass 2 will go at the same speed away. And that is how it happens. Now, secondly, if mass 1 is greater, it will come like a little Humpty Dumpty, and then it will happen, and they will both be going. It will go slower, because that is what happened in elastic collision. It must be conserved, like these will have same, but it will be going slow, but they both go forward. And then the second time, he come like a little rabbit foo-foo. He is smaller, and then mass 1 will go backwards. Mass 2 will go for hello, Asian man. And that is what happens. I guess this country, they like a licking people. I'm a little confused, but whatever. And that is the physics. You can solve for the masses and their specific velocities using these formulas derived from momentum conservation and kinetic energy conservation because it is elastic. Chinquig, please call my mother. Yes, Shemesh. It is me. I apologize.
What exactly does Yishamesh even mean?
Hey, you do not disgrace my family like that. I know you have a gun, but it is not
Okay,
right.
for one, I don't have a gun.
He is a racist. He has a gun. Do not trust him.
Okay, just
He
go
is
back
a
to your physics.
sneaky
I'm
man.
sorry.
Sneaky. Anyway, I just ate a big dinner of 6 dogs and a monkey, and now we will do an inelastic collision. It is, if you remember, it is the one where they bounce apart, but it is not conserving kinetic energy. This is like when a ball is dropped and it cannot go back the same height. It goes wee, 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 wee. Then another time it is completely inelastic. You drop a pencil and it just stay there. Like, what the heck? It is bored. It do not want to come back up. But that is completely inelastic. But for all of them, don't forget, momentum is conserved. Now we have when it happens, when it completely inelastic hit another ball that is stopped, they are added together and they do a velocity. You can use a maths. You can do mv equals mv final, and that means that you will have m1 v1 equals to a m1 plus m2 times vf. That is right. Asher's not beating me. He's giving me treat. Very nice. Shinkwig.
Kanishka, what are you doing?
I'm taking selfies. Do not disturb.
I think we have to go back to physics now. So, this is a problem that combines both conservation of momentum and conservation of energy. So, just explaining the system, your mass of this block is 5.4 kilograms, as it says in the problem. The height that it goes up is 6.3 centimeters. Remember, the SI unit for measurement of length is actually meters, so this is going to have to be 0.063 when you do all your calculations. Your mass of the block, or the mass of the bullet is 9.5 grams. But because you're going to be in kilograms, it would actually be 0.0095 kilograms. Now, let's think about this. When you're going up here and the bullet has already collided with the block, from the point where the block actually has the bullet to the point where the block reaches its final destination, that is the conservation of energy because there's no longer a collision happening. So you have TE I equals TEF.
Hey, Asher, look. I'm so glad they sell a monkey in your family. In your country, they grind
No.
up a monkey and flavor it blue raspberry.
No.
I'm so excited to eat the dynamo.
No, no. You just ruined my yogurt experience forever. So, at the end of this block's destination, it has reached a height where it's no longer moving. Therefore, the total energy final is only potential energy, so that you have mgh. Because it is at its lowest height here, it has no potential energy here, and is only using kinetic energy, therefore 1/2 mv squared. Now, the m in this case is both the mass of the block and the mass of the bullet, but it doesn't really make a difference because they can cancel each other out. So you have 1/2 v squared is equal to your 9.8 times 0.063. You then take your handy-dandy graphing calculator out, or whatever calculator you choose to use, and do the math.
In my country, we use a weight with the numbers to do adding.
Kanishka, why
Do
are
you
you
do
doing
adding?
this? I use a calculator, like a civilized person.
And that is racist. Do not say that again.
I'm sorry. Now, what you saw for this v is about 1.111 meters per second. Now, this v is the initial velocity that this block and the bullet possess. In this case, it's actually the final velocity of the collision. Now, this is an inelastic collision problem, so kinetic energy is not conserved because it's not completely inelastic. So, but you do have conservation of momentum, so your pi equals pf, both vectors. Your pi is your m1 v1, m1 being the mass of just the bullet, v1 being the speed of the bullet, which is what you're solving for in A. That is now equal to your mass of the block plus your mass of the bullet, all times the velocity that this is now moving at. The velocity that this is moving at is 1.11 meters per second. Plug that in, and you get 0.0095 v1 equals 5.4095 times your 1.111. You multiply these out, and you get something of the sort as v1 equals 632.75 meters per second. So that would be the answer to A. What is the speed of the bullet just prior to the collision? That is the speed, the initial velocity of the bullet. Part B asks for the initial kinetic energy of the bullet. So, all you have to do is 1/2 mv squared, m being your mass of this bullet, 1/2 times 0.0095, v being what you just solved for, 632.75 squared, and your calculation comes out to something like 1901.77 joules.
Hey, Asher, I failed the gym class. They gave me this and tell me to become cheerleader.
I highly doubt that.
I'm very good at it. Watch this!
Damn you, more TV! 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 Damn you, more TV!
This demo will show you when you combine two objects of the same mass, together they will travel at a slower velocity than the original velocity. Let's take a look. Now, why did this happen? Let's have a look at the math. So if you have one mass traveling at one velocity and you add more mass to it, you have to be traveling at a slower velocity afterwards, given this equation. It has to balance out. Now let's take a look at an elastic collision, where they come apart. Go. Now how does this work? Since in this case, m1 is equal to m2, the initial velocity that m1 is traveling at will be the initial velocity that m2 is traveling at, because it is conservation of momentum. Now let's look at one where the collision happens between two different masses. Well, what happened here? This was an elastic collision between a larger object and a smaller object. In this case, what happens is the larger object will keep moving while the smaller object moves at a smaller speed, but momentum is still conserved. In this case, the smaller object will actually move back as the larger object moves forward. The Newton balls are a classic example of conservation of momentum. You can almost see the momentum being transferred from the first ball into the rest of the balls and out with the last ball. You probably didn't catch that, did you? Let's watch it again in slow motion and see what happens. Now, when you bounce a ping pong ball, it doesn't usually go that high. This is because the momentum that originally was in the golf ball is being transferred into the ping pong ball. Because it's less mass than the golf ball, it's moving at a much faster velocity, making it go much higher.